Okay, so in this lesson, we're still in chapter 1. We're going over section 5, angle relationships. And before we move on to that today, we're going to do a quick review on what we've already kind of gone over and taken notes on. So I have these, 5 questions and a little picture over here. I'm going to zoom in. I'm just going to read the questions to you and we'll kind of go through them. And then I'll back up and show all the answers if you need that. Okay, first question is, name the vertex of angle 3. And angle 3 is this little guy right here. Okay, so the vertex of angle 3 would be point C. So we're gonna write point C if you're filling that out. All right, now B, name a point in the interior of angle ACB. Here's A, here's C, here's B. So we're talking about, I'm a visual learner, so I gotta color a lot. We're talking about this whole, everything in here, right? Inside this angle. So what's a point inside there? Well, if you're not sure about G, because this triangle ends here, if you're not sure what's going on, you can always ask yourself, well, is something else? Could that be the answer? B and C are on the line, so they're not inside the angle. A and D are on the line. They're not inside the angle. There's no other points here that could work. So yes, G, if this was a big gator mouth, it would chomp down on the letter G. So point G is on the interior of our angle. Okay? C, name the sides of angle BAC. Angle BAC. So we're looking at this guy right here. Okay, so we're naming the sides of that angle, the sides that form that angle. Remember that we talked about sides of an angle are rays, right? And if we're just talking about an angle, not a picture, nothing like that. If I were to just draw an angle, 2 sides of the angle are rays. So I would name this as a ray and this as a ray. Well, here in this picture, when I'm looking at the angle BAC, A is my vertex, but this is not a ray, right? It ends at B. It doesn't keep going past point B. It stops there. So yes, this is the side of our angle, but it's just a segment. It is not a ray. So when I name that, I'll scoot this over. When I name one side of angle BAC, I'm going to name AB with just a line over top. I'm not going to put the little arrow because it's not a ray. It doesn't have an arrow going past point B. All right, for this other side, AC, does it have an arrow that goes past point C? Yes, it does. So this is a ray. So you could call this ray AC. You could call it ray AD. As long as you name A first, that's the end point, and any other point on this side of A. Okay, so I'm going to call it AC. And it is a ray. So I put the little arrow on top, if that kind of makes sense. Just pay attention to that. It depends on the picture you're looking at. If it's not a picture, it's just an angle, it's always 2 rays make up the side of the angle. But in this case, we have more limiting factors. Okay, and then next question, D, name an angle with vertex B that appears to be acute. So here's point B up here. We have to name an angle that appears to be less than 90 degrees. Well, I don't know about ABC. Maybe it's less than 90. It kind of looks like it, but I'm not 100% sure. But definitely ABD. If I drew this line right here, this angle is definitely smaller than 90 degrees. So I could say angle ABD, or you could call it DBA. Doesn't really matter as long as B is in the middle. I could also say that DBC, this angle, is acute, right? Just this little bottom half area, DBC. You only have to name one. Those are just 2 different possibilities. I could probably say ABC, but that's not the most obvious answer choice to me. And since I only have to name one, I'm going to stick to one of these 2 that's more obvious. Okay, and then last question, if ray BD, which is, here I'll use colors, this guy right here, ray BD, bisects angle ABC. ABC is this guy. So whatever this angle, this entire angle thing here is, whatever it is, this red line bisects it. It means it cuts it exactly in half. So everything on this side is going to be the same size as everything on this side, our 2 angles. Okay, then it tells us that the measure of ABD, this top guy, is 2x plus 3. So I'm going to kind of redraw it down here. I'm going to have this, here, and I've got this bisector here, right? This top area is 2x plus 3. And then the entire angle ABC, the whole thing, this whole thing is 6x minus 26, right? And if this line right here, I'll make it red just like the top one. If this line cuts the entire angle in half, then doesn't that mean that this bottom guy has to also be 2x plus 3? It doesn't tell us that. It tells us that's what the top is, but the top and the bottom have to be the same. So I know each of these is 2x plus 3, and then it tells me the entire angle ABC is 6x minus 26. So I'm going to use that information to do a little math and solve. So I'm going to say 2x plus 3 plus 2x plus 3 equals the whole thing 6x minus 26. So 2x plus 3, and there's 2 of those, is equal to the whole thing, which is 6x minus 26. And now I'm just going to use algebra to solve, right? I got 4x when I distribute. 4x plus 6 equals 6x minus 26. I'm going to subtract 4x from both sides of my equal sign. So I'll get 6 equals 2x minus 26. I'm going to add 26 to both sides of my equal sign, so I'm going to get 32 equals 2x, and then divide both sides of the equal sign by 2, so I'll get x equals 16. But it didn't ask me to solve for x. It asked me to find the measure of angle ABD, so that's what I need to do. It also told me up here that ABD is 2x plus 3. So now that I know that x is 16, I'm just going to solve, right? 2 times 16 plus 3. Be careful in organizing all your steps. Make sure you're answering the question. 2 times 16 is 32. 32 plus 3 is 35 degrees. So the measure of angle ABD equals, sorry, I wrote that squished, that guy right there. Okay, hopefully that makes sense to y'all. All right, let's start over at the beginning of our notes. If you guys have printed these out and you are following along, it should look like this. Let me back up. Okay, and again, this is 1-5 angle relationships. So our essential question, I guess you want to say, is what are at least 3 types of angle relationships? What are at least 3 types of angle relationships? And, or you could say describe at least 3 angle relationships. By the time we're done with this lesson today, you'll be able to do that easily. Okay, so then we have a couple vocabulary fill in the blank things here. And again, I'm a visual learner, so I got to use colored pencils and colors. Okay, a blank is a pair of adjacent angles. Adjacent means they're right next to each other. They're side-by-side neighbors. They're touching. So a blank is a pair of adjacent angles with non-common sides that are opposite rays. Okay, what? Well, first I'll tell you that the answer is linear pair. L-I-N-E-A-R. Sorry, my handwriting stinks. L-I-N-E-A-R, pair, is a pair of adjacent angles with non-common sides, means the side that they don't share, right? Adjacent angles always share a common side. These are 2 adjacent angles. They're like next door neighbors, right? If this is your yard and this is your neighbor's yard, you guys are going to share a fence line, right? It might be your neighbor's fence, it might be your fence, but you're both using it. That's shared. It's a common shared side, okay? So for 2 adjacent angles, the non-shared sides, the non-common sides, have to make a straight line when you're talking about a linear pair. They are opposite rays. Okay, so which diagram includes a linear pair? Which diagram has a straight line, perfectly straight line, and the 2 angles make up that straight line? this guy right here. Does this have a straight line anywhere and two angles sit on that straight line together? Well, no, these two angles aren't sitting on the same straight line, right? This line's not straight, this A line's not straight, it's like all crooked. Looks like they're kind of bent or broken off. So we're going to eliminate this guy. That's not correct. But this one is. So here's our straight line. And basically you just need to remember that a linear pair are two angles next to each other that add up to 180 degrees. So we're going to say angle 1 plus angle 2 equals 180. And that's all you got to know about a linear pair. Two angles side by side make up a straight line. The next one, blank, are two non-adjacent angles. So now I'm not talking about a line, I'm talking about angles, and they're not right next to each other. They are non-adjacent, they're not next door neighbors. They're angles formed by two intersecting lines, and which diagram shows that, okay? So this is going to be vertical. Oh my gosh, I just spelled vertical wrong. V-E-R-T-I-C-A-L angles. Wow, this stinks writing in colored pencil. I'm not going to do that again. Vertical angles are two non-adjacent angles formed by two intersecting lines. So here, if I have this straight line and this straight line crosses through it, I have two sets of vertical angles. Vertical angles, we also call it bow tie angles because they're right across from each other, right? These two red angles, doesn't that kind of look like a bow tie? Absolutely. Also, this bottom guy is straight across from this top angle, right? So vertical angles are across from each other and they share the same vertex. They look like a bow tie. So this is correct. This is an example of vertical angles. We could say that angles 3 and 4 are the same size. They're congruent to each other. Vertical angles are always the exact same size. So angle 3 is congruent to angle 4, the two red guys here. And also, these top and bottom angles are vertical, angle 1 and 2. Angle 1 is congruent to angle 2. So those are our two sets of vertical angles. Now, why is this not an example of vertical angles? If we zoom in a little bit, I don't know if that helps. Here, I'm like running out of room. Okay. Because this line right here is not one straight line. It's actually bent a little bit if you look, right? And vertical angles are formed by two straight lines that cross over each other. AC is straight, but this whole DEB thing, it's broken. So it does not make up vertical angles. This does not work because the line is not straight. We'll say not a straight, did I need to move that over? No. Line. Has to be two straight lines crossing over each other. All right, let's do a few examples. Let me back up enough for us to see it. I'll just have to scoot over. All right. For 1, 2, and 3 here, we're going to be looking at this guy. So I'm actually going to zoom in just so we can kind of talk about it while I'm asking the questions. Let me move my phone over. All right, angles 1 and 2 are adjacent angles. We have to tell if that's true or false and then explain if it's false. Okay, 2 and 5 are adjacent angles. Here's angle 2, this guy right here, and here's angle 5, this guy over here. Are they right next to each other? Do they share one common side? No, they're across from each other, right? I've got this guy over here and this guy over here. They are across from each other, but they do not share one common side. They're not next door neighbors. They don't share one fence line, right? So they're not adjacent. So we're going to say that's false. No common side. Okay, number 2, angles 1 and 4 are vertical angles. Here's angle 1, here's angle 4. I'll highlight them in red. Sorry, it's so loud when I clank my pencils down. Okay, does that look like a bow tie? Absolutely, yes it does. Do they both share the same vertex? Absolutely they do. Are they formed by two straight lines that are crossing over each other? Yeah, should look like an X, right? So they're two angles across from each other. They share a vertex formed by straight lines. These angles are also the same size. So yes, that is true. Angles 1 and 4 are vertical. True, sorry. And then the last question, number 3, angles 4 and 5 are complementary. So here's angle 4, this red guy. Angle 5 is this big old blue guy. What does complementary mean? What are complementary angles? They add up to 90 degrees. Complementary is 90 degrees, okay? These add up to a straight line. So what does that mean if they add up to a straight line? What do they add up to? 180 degrees. These are supplementary. So the answer for number 3 is false. False. They are not complementary. They are supplementary. They add up to a straight line, not a 90-degree angle. I'm just going to abbreviate there. They're supplementary. So is there a complementary angle to angle 4? 5 isn't. They don't form a right angle, but what does form a right angle with angle 4? What about angle 3? Yeah, it's even marked with that little box in the corner. If we just got rid of this arrow right here, 3 and 4 together make up a 90-degree angle. So here we could say, we can mark this out and say angle 3. Angles 4 and 3 are complementary. All right, next one, example 2. So I'm going to read the questions. We're going to look at this little picture. It says, name an angle or angles in the diagram described by each of the following. We need to name an angle that's complementary to BOC. All right, so here's point B. O is right here. C is here. So we're talking about this guy right here. And we want an angle complementary to that. Complementary means 90 degrees, right? So how do I know what's 90 degrees? Well, look, I've got this straight line here, and this is marked 90. So 2 angles that add up to one straight line are supplementary, right? They add up to 180 degrees. So this angle is 90. 90 plus what equals 180? 90 again. So this angle on this side, this line and this line form a 90-degree angle. If this guy is our angle, what's complementary to this angle? This angle right here. We just marked them. Those two together form this little square, this little 90-degree angles, right? This line and this line form a right angle. So we're going to say angle BOA, or you could call it AOB. Doesn't matter. Angle BOA. I'm going to use BOA because I like BOA. All right, number 2, what's an angle supplementary to DOB? Here's D, here's O, here's B. So we're talking about this whole angle right here. Supplementary angles form a straight line. So here's part of our straight line. What other angle forms the rest of this straight line? This little blue angle right here, right? We've already got all this taken care of. What else with this whole big angle makes it go all the way down to a straight line? This little guy again, BOA, same angle. I hope that's making sense to you guys. And then third, adjacent and supplementary to AOC. Adjacent and supplementary to angle AOC. Here's A, here's O, here's C. So it's this right angle here that we talked about in the first one. The red and the blue together. It has to be adjacent and supplementary. So if we just kind of ignore this little line here and we think of this whole angle, what angle is right next to it? They're like next door neighbors, they share a fence line, and it also adds up to 180 degrees. Well, if this whole angle that we're talking about is 90, this angle right here is 90, isn't it? It's marked that way. And it's like directly next to it. They would both share this side. So this angle DOC, or you could call it COD. Questions? Make sure you let me know if I'm going too fast. I don't know when I don't have kids right in front of me. Okay, next example. Says algebra. Ooh, exciting. 3A, find the measure of 2 supplementary angles. I always got to mark up what the question is so I don't lose track of stuff. 2 supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. So I've got to find the measure Find the measures of two supplementary angles. Two supplementary angles add up to a straight line. So I basically have like this. I've got this angle, I've got this angle. This guy, this guy. I'm gonna mark them differently. So this angle here, me and my color coding with everything. I don't know which is which, right? It doesn't tell me, well, the bigger angle is this and the smaller angle is, I don't know. But it just tells me that one of my angles is 6 less than 5 times the measure of the other angle. I don't know what the other angle is. I'm just gonna call it X, right? I don't know what it is. When I don't know what something is in math, I use X to represent it. But it tells me that the other angle is 6 less than 5 times whatever this one is. 6 less than what? Than 5 times the measure of this angle. If this angle is X, then I'm gonna have 5 times that measure, but not just 5 times that measure, it's actually 6 less than 5 times that measure. So I'm gonna subtract 6. 6 less than 5 times the measure of this other angle. So these two angles together are supplementary. So I'm gonna add them together and set them equal to 180. 5x plus 6 plus the other angle, x, equals 180. And sometimes when you're like I always have to draw a picture. Sometimes if you do that, it'll end up being like I'll get a smaller angle and a bigger angle. And let's say one might be like, I don't know, 20 degrees and one might be 70 degrees. And the way I drew it, it looks like this one would be 20. Well, when I do the math, it might end up being that this one's 20 and this one's 70. And that's okay because we didn't know which was which to begin with. As long as the math works out, the picture doesn't really matter. Okay, so we add all this together, we solve for x. I've got 6x plus 6 equals 180. Subtract 6 from both sides of my equal sign. Divide both sides by 6. 6 goes into 17. Almost 3 times, 2 times. 6 times 2 is 12, 54. 6 goes into 54 29 times. So I should get x equals 29, but it doesn't ask me just to stop at x. It asks me for the measure of both of those angles. What did I do? Did I write this different? Y'all, you gotta catch me. Dang, that's what we preach to you guys. Don't make little mistakes, and I totally did. 5x minus 6. This should be minus, not plus. It should be minus 6. Okay, so then here, when I get rid of it, I'm gonna add it to both sides. So on this side, I should get 186, not subtracting at 174. At least I caught that one before just finishing the video. All right, so then I divide both sides by 6. I've done this already, and I knew that didn't feel right. 186 divided by 6 is 31. So that's my first angle. That's this guy, 31 degrees. And then I have to find the other angle, so I'm just going to plug x into it, right? 5 times 31 minus 6. 5 times 31 minus 6. 5 times 31 is 155. Minus 6 equals 149 degrees. Now, for us to know that these are the measures of our two supplementary angles, they got to add up to 180, right? So if I add them back together, 31 and 149, do they add up to 180? Yes, they do. All right, and then that was a good lesson in paying attention to your signs. That was a dumb mistake. But it happens, and I fixed it. We move on. Okay, perpendicular lines. Perpendicular lines intersect to form 4 right or 90-degree angles. And we're going to draw a picture down below. So that's our first rule on perpendicular lines. Next, perpendicular lines intersect to form congruent blank angles. Congruent adjacent angles. So all the angles next to each other, when you have perpendicular lines, they're all 90 degrees. And then lastly, segments and rays can be perpendicular to, well, segments and rays are types of straight lines, right? Just like pieces of lines or half a line or whatever. So they can be perpendicular to other types of straight lines. So we could say they can be perpendicular to lines, line segments, and rays. Okay, so what is perpendicular? It's the opposite of parallel. Parallel is when two lines are right next to each other. They never touch. They're going at the same rate. Perpendicular, oh, my fingers look awful. Perpendicular lines cross each other at 90 degrees. So we would use the symbol that looks like this. I think of like a floor with a beam coming down into it. It looks like an upside down T. That symbol means, when you see that and you read it in a solution or an equation, it means is perpendicular to. Okay, so let's draw an example. Let's say I have this straight line, and then I have this straight line, and they are perpendicular. If they are perpendicular, they form 4 right 90-degree angles, okay? So this angle, ooh, that messed up. This angle is 90 degrees. The one next to it's gonna be 90 degrees. The one next to that's gonna be 90 degrees. If they're 90, we can put that little corner thing in, right? And the one next to that's gonna be 90 degrees. So it forms 4 90-degree angles. 90 degrees, 90 degrees, 90 degrees, 90 degrees. And so if all of the angles are 90, then the ones next to each other are both the same size. They're congruent. They're both 90. The ones across from each other are congruent. They're both 90. All the angles here are 90 degrees when 2 perpendicular lines intersect. Okay? And it doesn't have to be lines with arrows on the end. It could be 2 line segments, right? I could have endpoint to endpoint like that, and another segment, endpoint to endpoint like that, and they all form 4 90-degree angles. They're perpendicular. I could have a ray, endpoint and then arrow go up forever, cross over a line that has arrows on both sides, right? Any type of straight, sorry, I'm hitting the table, straight line or ray can be perpendicular to anything else. That's why we wrote this last line. If it's straight, it can be perpendicular to something. Okay, almost done. Got a little vocab to write down, and then we're good. Okay, so before I answer this little guy, I'm going to fill out this square. It's just basically, there's one big square in the notes, and I separated it into 4 sections. So we're just going to write down our vocab. We've been talking about it. We're just going to be more specific in writing it down. So for the first one, we're going to write down a picture, show a picture of supplementary angles. This is like a quick cheat sheet guide, right? So if I have a straight line and another line coming out of it, these 2 angles are supplementary. So I'm going to say they make up a straight line. They add up to 180 degrees, and they are supplementary angles. These 2, okay? So at the top, I'm going to say supplementary angles are 2 angles whose sum equals 180. 2 angles whose sum, meaning when you add up the measure of each one, it always adds up to 180. It always adds up to a straight line. So those are supplementary angles. The next one that I'm going to go over is vertical angles. We went over that in the front. So if I had a big X like this, and they don't have to be perpendicular. Actually, most times they're not going to be perpendicular. They won't form 90-degree angles. They might be like a really skinny bow tie or a really fat bow tie. You'll see a lot of them. But if I have 2 lines that intersect, the angles across from each other, like this guy and this guy, forms what looks like a bow tie. Those are vertical angles. They share a vertex. I'm gonna write vertical angles. Can y'all see that? Yeah. And a vertical angles are 2 angles across from each other formed by 2 intersecting lines. 2 angles across from each other formed by two intersecting, two lines, two straight lines that cross over each other. Doesn't matter if they're perpendicular or not. Usually they're not going to be, but when you have kind of an X-looking area, it forms two sets of vertical angles. Okay, the next one we talked about was complementary angles. So supplementary is two angles that add up to a straight line. Complementary angles are angles that add up to a 90-degree, one big 90-degree angle. Okay, so I could have that and like this. And let's say this guy is blue. So I've got my two angles and they both add up to 90 degrees, so they are complementary. Complementary. And complementary, when you're talking about adding up to 90 degrees, they don't have any eyes in it. It's not a compliment like, wow, you look really pretty today. Not that type of compliment. Compliment like along with another angle, it completes the equation. They add up to 90 degrees. Complementary angles are two angles whose sum equals 90 degrees. Supplementary is 180, complementary is 90. And then the last type of angle relationship we went over was adjacent angles. So if I have maybe like straight lines like this, and then I just stick another line in here, these two angles next to each other, let's say this one is one measure, and then this one is a different size, but either way, they're right next to each other, and they share a common line, right? Next door neighbors, they share one fence line, something like that. Did y'all ever have that? I remember growing up and we had we didn't have a swimming pool, and my next door neighbors did, and we could see over our fence into their pool whenever they'd be out back like laughing and stuff, or they'd kick a beach ball over into our yard and be like, can you send it back over here? Like, can we come over and swim? It was so unfair. But we could look over our fence line and see it. We were adjacent. So adjacent angles. Two angles that share a common side and vertex. Two angles. All right, so those are kind of our vocab, what we went over. These are our angle relationships we talked about in today's notes. Supplementary angles, complementary angles, vertical angles, and then adjacent angles. They're right next to each other. All right, next example is over here to the side. Find the measure of two complementary angles. So we got to know that two complementary angles add up to 90. If the measure of the larger angle is 12 more than twice the measure of the smaller angle. What? Well, first of all, I'm going to draw what I think are two complementary angles, right? And it says there's a larger and a smaller. So I'm going to draw this, and I'm going to say this is my smaller angle, and this one's going to be my bigger angle. And so I don't know what either one is. The measure of the larger angle, so this guy, is 12 more than twice the measure of the smaller angle. Well, to do that, I got to figure out what's the measure of the smaller angle. I don't know. So anytime I don't know the size of something, I'm just going to call it x. This is x degrees. This is the smaller angle. So then I know this bigger angle is 12 more than twice that. Okay, so it's twice this, two of those, and 12 more than that. So I add 12 on to the end. So I've got my little angle, I've got my bigger angle, and I got to figure out what the measure of both of them are, right? Find the measure of two complementary angles, if that's the criteria. So all I'm going to do is add these together, set them equal to 90, and solve for x. Once I know what x is, I can plug it in. So 2x plus 12 plus the smaller angle x adds up to 90. 2x plus x is 3x. Then I have that 12. I'm trying to solve for x, so I subtract 12 from both sides of my equal sign. That's 78. And then I have to divide both sides by 3 to get x alone. And so that's going to be 3 is 8, 6, yep, 26. But it didn't ask me to solve for just x, it asked me to solve for the measure of the two angles. Well, I know the smaller angle is x, right? So this is my smaller angle. Now I got to figure out the bigger angle. So I'm going to plug it into 2x plus 12. Oh, can you see that? Yeah, barely. 2, now I know x is 26, so 2x plus 12. 2 times 26 plus 12. 2 times 26 is 52. And 52 plus 12 is 64. So I know one of my angles is 26 degrees, the other angle is 64 degrees. And I don't have a way to name my angles, but it doesn't really matter which is which. It just said find the measure of two angles. So I know one of them is 26 and one of them is 64. Last example, are you so excited? Last example, yay! All right, find x and y so that line KO and line HM are perpendicular. All right, and we're looking at this guy right here. So KO and HM are perpendicular. Here's KO, this straight line KO, and here's line HM. And they are perpendicular, which means that they form 4 90-degree angles, right? So this is 90, this whole corner is 90, this whole corner is 90, this whole corner is 90. Okay, it says find x and y. I'm solving for x and for y. Well, I notice here that I've got x's within this quadrant, I guess, or this one 90-degree angle. And I notice that my y's, I just have one y, is over here in this 90-degree angle. So using what I know about 90-degree angles, how can I solve for x and y? Well, first of all, what do I know? If KO is perpendicular to HM, then what? What could I say based off of this picture? I can say that this blue angle is 90 degrees and this green angle is 90 degrees. Once I know they're both 90 degrees, I can solve for my variable. So I'm going to say the measure of angle KJH equals 90 and the measure of angle, this other guy, MJO equals 90. All right, so once I know that, then I can start setting stuff equal to stuff, right? So first of all, I'm going to solve for x. To solve for x, I got to add these two angles together and set them equal to 90, because I know this whole corner that I shaded in blue adds up to 90. It's a a right angle, 90-degree angle. So I'm going to add for x, to solve for x, I'm going to add 3x plus 6 plus this other angle, 9x, and together they add up to 90. So I solve for x. 3x plus 9x is 12x. I still have that 6. I need to get rid of that 6, and it is a plus 6 this time. So minus 6 on both sides, 12x equals 84. And then divide both sides of my equal sign by 12, and I should get 7. And it just told me to solve for x and for y, so once I get x, I'm done with that part. Now I can solve for y. For y, my only y here is over here in this green angle. So I'm just going to set this entire green angle is a 90-degree angle. So I'm just going to set 3y plus 6 equal to 90. To get y alone, I got to subtract 6 from both sides of my equal sign. So I get 84. And then I need to divide both sides of my equal sign by 3. And I'll get y equals 28. So I got x and y, x is 7, y is 28, and that's all it asked me to do. Okay, so you're going to have an assignment on this. I want you to do your best on it. Go back and watch the video, and then shoot me any questions if you have them, if anything was confusing. Thanks.